Hey there, I'm Ken, the Metal Professor, retired math professor and host of a heavy metal radio show, and that explains the ridiculous name. A lot of times on math forums, you'll come across a post where someone has asked, how do I learn math? And that's a big question. So I thought maybe I would take a few minutes and try to lay out a pathway that might be suitable if you want to learn math, and also depending on your starting point. Because, like I said, boy, is that a loaded question. Now, the scenario I'm going to lay out is not the be-all and end-all. And in fact, a lot of people might say, well, wait a minute, I learned this in a different order, or that stuff wasn't in this class that you said it was in. And everybody will have different experiences in different places. Mine is coming from a career as a student and a professor in United States math departments at the kind of liberal arts range, where you're dealing with math students that are in a broad audience. So you do have math majors that really want to get into the weeds, but especially at certain levels, you're with people that sort of want they're taking math classes because they have to for their major, right? So they want the more drive-by approach, but some of them may decide to minor in math because they liked it, or maybe even pull a double major in math. And because I'm talking about college, that doesn't mean that's where I'm going to start. It's just that that's one of the places where people start getting on their own personal path about what they want. So this is just a loose guide. And the story is going to be in two parts. One is how do the subjects trail from one to the next? And also, how do you go find books to use to help you learn math, either as supplements in a classroom or just because you want to learn some of it on your own? Okay. So I'm going to assume that if you want to learn math, you've at least had some basic experience, and maybe we're starting looking at it from the basics in algebra. You've already been through arithmetic and all this stuff and probably have experienced algebra, but this is where we'll start talking about how the study of math can filter out. Now, after you've taken your first experience with algebra, like in the United States, that's generally around 7th grade in middle school somewhere. After algebra, if you're laying out your high school curriculum, some people will go to geometry in their trajectory. There's also an Algebra 2 class. Some people might go algebra to geometry to algebra 2. Some people might just have a couple of algebras back to back, but once you've taken a foundation in regular old algebra, learning some good geometry or going deeper into algebra are both perfectly fine ways to go. There's also a version of algebra that's called college algebra. And again, that's one of those catch-all phrases that is a big umbrella it's often taught as its own course, but it's certainly going to follow like a second algebra. For my personal experience was I took my first algebra in, I think, 8th grade and took algebra 2 in 10th grade, but that had some stuff in it that probably could have been called college algebra. Once you've had a good foundation in algebra and also some trigonometry, you are then ready for, with geometry, then you're ready for trigonometry, getting into your good old sines and cosines and things like that. Also, once you have a really good foundation just in manipulation of quantities and expressions and things like that, you're probably ready to try out some, might call it baby stats or introductory stats, to get that sort of experience. And a lot of high schools will have statistics courses as well. So again, depending on your goal, if you're a new learner and maybe you're trying to go back and pick up again where you left off a long time ago, you sort of have to have in mind what trajectory you want to take, because even at this level, there's all sorts of different ways that you can go. But these courses around here are about when you're starting to make that transition out of high school and into college math, unless you're on a more advanced high school trajectory. Very often, an experience that combines college algebra and trigonometry might be called pre-calculus. And the name gives it away, right? There is no reason to take pre-calculus unless your goal is to then take calculus. And even if you had an intro stats class in high school before college, maybe you can take it early on in college. And so these are the subjects, maybe a first stats course or a pre-calculus course that really launch you into where you might want to consider going after that. After a good solid grounding in pre-calculus, you might find yourself on different paths. So again, it's all about what it is that you want to study and why. Like I said, pre-calculus is by default a precursor to a first semester in calculus. And I'm reaching over because I can tell my dog wants a pet, but as soon as I reached over, she ran out of the room. Meanie. A lot of people in a business type track after a pre-calculus or a college algebra experience might go on to a class called finite math, which is it's like a hydra. The finite maths I've experienced have like 4 different subjects crammed into a single semester. So it's quite a hodgepodge of a course in a lot of cases, but a lot of those tools that you learn can be brought to bear in a more business or finance, psychology even type of environment. Whereas Calculus 1, you're starting to lean more into the hard STEM type things. Maybe some economics and business as well in some places will require calculus. Some might not. It all depends on the institution. But once you've had pre-calculus, going to finite math or calculus 1 is the next thing. You don't need a lot of the content in pre-calculus to take finite math, but you really need to have brushed up just on your problem solving skills. Finite math is not an easy class. And so being confident in your ability to handle expressions and do manipulations and things like that is essential for success in that class. And pre-calculus is one of the classes that gets you prepared for that. Every class is not necessarily about what you're learning in terms of subject. It's about the problem solving skills that you're gaining along the way, right? Now, suppose you've had an intro stats experience either in high school or early on in college. If you then also had calculus, then you're ready for what I've called the real statistics, because learning statistics with calculus is much more powerful than learning statistics without it. After Calculus 1, you're ready for Calculus 2. Calculus is a huge subject, and it's very often broken up into multiple different semesters. Finite math, if you're on that path where you take finite math, you might be off to a whole different universe after this and not even come back to any math-specific classes. But there are some classes that couple well with finite math. So you may not want to neglect the opportunities to study math along the way. After Calculus 2, it depends on your university and how it's laid out. Some places have 4 semesters of calculus. Some places have 3 semesters of calculus. You just never can tell. But after Calculus 2, assuming everybody's Calculus 1 is mostly similar, no matter where you are, it's limits, derivatives, applications of derivatives, a little bit of what's called optimization, and also very basics of integration. Then you go on to Calculus 2, which is more advanced integration. In classes or in universities that have 4 semesters of calculus, there's a topic of sequences and series that some places might be in Calc 2, some places might be in Calc 3, right? You have to track down what it is you're looking for. But after single variable calculus, which Calculus 1 and 2 embody altogether, you might be ready for multivariable calculus. And also after Calculus 2, you're ready to study differential equations. That's good stuff. Some places will put a little kind of baby introduction to differential equations embedded in a Calculus 2 class. If you are on the more statistics type of path and you've had your intro stats and you've taken calculus and you've taken now a real statistics course that has calculus tools in it, then you're ready for some more advanced classes on probability and statistical theory. The reason there's no arrow from intro stats to Calculus 1 is that you don't need to have taken intro stats to get to Calculus 1. But the combination of Calculus 1 and intro stats gets you to a more advanced statistics, which then leads to more advanced statistics and probability classes. Okay. This particular combination here of calculus the tail end, the more advanced single variable calculus and calculus 2, multivariable calculus and differential equations. That bundle together makes you eligible for partial differential equations. And this is like super advanced stuff that either can be taken just because you want to study it, but is also very, very applicable to the S, T, and E parts of STEM, science, technology, and engineering. But plenty of people that are just studying math for math will take partial differential equations as well. And then if you've taken everything in the circle, you're ready for linear algebra. A lot of people will take linear algebra before multivariable calculus. Taking multivariable calculus before linear algebra is an advantage in linear algebra. Taking linear algebra before multivariable calculus gives you an advantage when you take multivariable calculus. There is some overlap between those two. But there's a big box around linear algebra because once you've succeeded in that class, that's your launching pad to much more upper level theoretical math. Everything up to this point, again, at the utilitarian math level of most people in these classes are taking them because they're required for their major, right? Not because they want to study math and only math. These are very applied math classes, lots of problem solving. Linear algebra could very well be the first one where you experience a lot of having to write proofs and make arguments and deal with definitions and proper notations and things like that. Once you've had that, you're ready to launch into the deeper end of the mathematics pool. And again, that's not to say that you can't study these things in a very, very theoretical way, but the audiences that I normally dealt with, we had math majors in these classes and they would do fine, but they really wouldn't hit the jackpot until they got to linear algebra. Some schools are big enough that they can teach in two entirely different tracks of calculus, one for the STEM folks and one for the math folks, and those courses would be entirely different things. Well, here's the deep end of the pool. After partial differential equations, maybe you can take complex variables. This is very excellent for physics and engineering, even if you're not taking it just to study it for its own sake. Once you've had Calc 2 and multivariable calculus, with some linear algebra, that always helps because you need to learn how to deal with matrices. You're ready to take a class in optimization, which is, again, a very, very business-friendly kind of course. How can you do things such that you expend a minimum amount of resources or you retain a maximum amount of revenue or profit? How do you optimize your scenario according to your objectives? That's what optimization is about. And there's a little bit of optimization built into Calc 1 and multivariable calculus just to get a flavor for it, but you can take a full-blown course in it down the line, and you might use heavy-duty numerical tools in that or not. It just depends. Real analysis is where you go back and restart calculus, except do it right. You learn that everything that you learned in Calc 1 was a lie, and you take a much more deeper and theoretical look at calculus. Real analysis is basically a math major course. And once you're in the deep end of math and you've had your proof-based linear algebra class, you are ready just to jump to, oh boy, a whole bunch of other different things that aren't even necessarily related. And at this point, you really have to, you'll already have decided what you like, what you don't like, and you'll know what these words mean. Some of these classes, combinatorics, topology, I mean, rings and fields, that sounds like something you would play outdoors at a picnic, right? I mean, even the names of these classes make no sense until you've had some upper level math to learn what these words mean, right? But at least from, again, from the very basics, going up the ladder to just about into college, what are some of the paths in math you can take when you get to college? If you decide you like upper level math, what are some of the things you can do, right? That's the big story. And at this point, if you're taking these classes, you're a mathematician. You are ready to go study in graduate school in math as well. Or maybe you've had a second math major to go along with something else. But clearly you enjoy it if you have voluntarily subjected yourself to these things. So that I wanted to show this path because, again, I want to learn math. Where do I start? It depends. It depends what your goals are, what's your existing experience, what are your objectives? Are you going to apply math to science and technology? are you going to learn math for its own sake, right? Different objectives are going to take you on different pathways. Now, how do you learn this stuff? What are the magic textbooks? And the answer is there are no magic textbooks. Again, it depends on your objectives. Are you trying to dive in at the deep theoretical level right from the ground up? Or do you just want to kind of experience the topics for the first time, learn a little bit about them, and then decide what you liked best, and then go back and take a deeper dive? Or maybe you end up hating it and you don't want to see it ever again, and that's fine too. Okay. So you have to know the subject you want to study. And at these lower levels that I've been talking about here, you know, the upper high school, early college level, there's tons of books out there, and a lot of them are free. So let's start there. So I'm just searching on open source math textbooks. Okay. And one of the first hits that we get is a platform called OpenStax. And this has a really good library. Okay, yep, you need money. This is a really good library of books that you can just download. They're in PDF form. They're built just like the regular old math textbooks that you know and love. And you can climb the ladder quite a ways with these books. Here's one on algebra and trigonometry, and then Calc 1, 2, and 3. There's just basic algebra. Contemporary mathematics will be some pretty basic stuff. Introductory business statistics, pre-calculus. Okay, so there's all sorts of starting places here. And I'm going to suggest that this is as good a place as any to start. I'm not associated with them, right? I don't need to. It'd be nice if they raised money, but that's not my goal. I'm not tied to them. I use these as resources very often. They're kind of standard textbooks. They have information about the material, and most importantly, they have problems that you can practice with. And it actually doesn't matter so much what book you pick as what is going to be your level of dedication to trying out problems and exercises, because that's how you learn this stuff. You don't learn how to throw a 40-yard pass as a quarterback to hit your receiver on the nose just by watching film of other people doing it or reading books about how to do it. You've got to get out there and do it. You've got to practice. Okay, so any book that has a good number of exercises in it is going to be a good book, up to editing and stuff like that. But again, there's probably some bad choices in books. There might be some better choices, but you just got to start somewhere. And the free ones are a good place to start. The open textbook project here at UMN, I believe that's University of Minnesota, maybe. Again, lots of free books. Here's one on introductory algebra right off the bat. Now, if you scroll down on the page, they start getting a little bit weird, but you could go back and search for different topics that you want. Open Textbook Commons, right? Another hub of open books in a lot of different disciplines, one of which will be math right there, 177 resources. Okay, here's a book on mathematics with topics in algebra, calculus, geometry, statistics, and so on. Again, these are all freebies. The Open Library, I think this is the one that is web-based. Well, no, it isn't. One of the, I was making sure this was going to work earlier. LibreText, is this it? One of these is a web-based set of content where you're not going to download PDFs. You're going to go through the book through the web page, but that's fine. The story here is just search open source math textbooks, and you're going to find math textbooks for lots of different subjects, and those will get you started. Now, once you start experiencing a topic and you decide, hey, I want to learn this a little bit more deeply, then what you can do is go find some math forums online. And go find some forums where people seem to talk about the subject that you're interested in. You can try Reddit. You can try Stack Exchange. And I'm sure all these questions have been asked before, so you don't even have to have an interaction with anybody. You can just search, again, where somebody has asked, what's a good textbook to learn calculus? And a lot of people are going to recommend some older really intense theoretical books that will explain calculus from the ground up And if that's where you're at, then cool. That's a great recommendation. But again, you may be on the path where you want a more drive-by approach to calculus, and that's where the open source textbooks go. Just get out there and ask questions of the right people, or go find where other people have already asked those questions, and that will take you to calc books. The piece of advice I will give you about textbooks, because holy cow, I've already talked for 20 minutes, so I need to shut up, is that the thinner the textbook, the scarier it is. Okay, so if you want something that's a broad-based approach with lots of examples and fluffy writing, get one of those books that's a brick. Okay, if you want the really, really heavy-duty theoretical book, get one that's on the same subject but is really, really thin, and that's going to be the nightmare book, which will challenge you to death. Okay, that's my advice on textbooks. So I hope this has helped, basically with the story that there is no one perfect path through studying math. You have to know what your objectives are, why you want to learn it, and what is your background already so that you know where to pick up. But I hope this has helped.